When performing operations between a data frame and a series, the index and column alignments are similarly maintained. Right? Last time I made you, right? So the alignments, column alignments, and index alignments review was preserved, right? So that nothing got messed up. Right? Everything, the data, everything was intact. Nothing got messed up. So the same thing happens when we do operations between a data frame and a series, right? All right, let's look at some of these examples. Okay, so here we go. So let me just copy and paste this code. Okay, so we're just creating a two-dimensional array, right here. Okay, so outside. Okay, so rather I can do import numpy as NP, okay, and I can do a is equal to NP dot random dot random. Okay, so that's it. Okay, so here we go. Okay, this is my A. So this is as you can see 3x4, okay, 3x4 array iota. Okay. So now we're going to make what a data frame out of this. Okay? So first we're going to do this. A minus A0, whatever you want. If I do A minus A and the A0 okay, first let me see. I understand. So A0 I do A0 because this is just an array. This is a two-dimensional array, not by array, right? Okay, so if I do A0, what do you think?
7863.
That's correct. Hey, it skips you the first row, right? Your row, your first row. And if I do A minus A0, A minus A0, let me see. It's like a key operation just the one. B bata broadcasting. Yes, that's right. Hey, but if you see, you're thinking so let me quickly show you. Some broadcasting, of course, right? So, okay. Broadcasting. Yeah, I think we saw that last time as well. I can bet still. You A by value, right? And A0 came on A minus A0, right? A minus A0. So A by value and A0 is given to broadcast by the 7863, right? So you can give it 7863, 7863, right? And the result came to now you individually you element wise and so 0 0 0 0 value minus and you next came to the next row first there counts
-7.
-7 minus
-3.
-3.
Any?
3.
3
3.
minus 3. And minus 3.
-3.
Any period -3. Okay, very good.
-3.
Right? And next make it 0,
Z.
-8, 3, and 4.
3 and 4.
Right? Anyway, so okay, let's quickly check. Yeah, looks correct. Right? -7 minus your value 0 -8 3 4. Right? So yeah, correct. Right? So yes, 3 1. Right? So you guys know how it works, right? Okay. So now let's do the same operation. How it works with data frame. Right? Our data frame right? Basically, what we can do is we can create data frame out of the same array. The array is a data frame ID. Is that EF is equal to data frame and A, which is this array A, and a column say QRST. Right? It's going to have a Q, R, S, and T. Okay. So rather import and this SPE. Okay. So, and then let's see. So when you run that code again, okay, so here, so this is my df. It's the same, exact same, right? Same name, as you saw here. This is the same array. Right? It's the same array. This now what's the data frame, by the way. Right? This is data frame. So what if we do the same thing? Similar. Let's see. What happens here? So once we do that, okay. So yeah, so df minus df.ilog0. Okay, so what if I do this? df minus df.ilog0, right? So although see the ilog nagari pani huncha, tara it's better to use, use explicitly, specify which index you need. Yes, say ilog भनेको के भयो, implicit कि explicit? Is it implicit or explicit? ilog. Implicit, right? That's all you need to remember, right? Okay, and then let's see what happens. See, pretty much we got the same result. Yeah? So 0, 0, -7. So we got the exact same result like last time, right? So this is my course. Right? So about this figure, if you want column-wise operation, right, you can do that, right? So you can use the object methods with access specify, right? So if I want to subtract, for example, this column, the first column from all of the columns, right? It's the Q. I want to subtract Q from each of these. So the Q by the Q name subtract garne, right? R by the Q subtract garne, S by the Q subtract garne, T by the Q ni subtract. So how can I do that? Right? So for that I can use df.subtract, subtract. So please turn off your mic. Turn off your mic because your mic can answer. Let's do it again. Please turn off your mic, please. Okay, thank you. All right, so df.subtract, okay? And then I'm going to subtract this df not ilog0. Let's see. Oh, yes, for Q subtract. And this was the axis, right? Axis equal to k column ma garnu paryo भने के
0.
0. Yes. Oops. Okay, I messed up somewhere. Okay. Did I do? Let me see. Nope, sorry. DFS. Okay. Well, yeah. Yes, yes, of course. If not, because I'm supposed to subset the column. I know. So yes, of course. I just say Q nigger. df.q, df.dfq, right? dfq, x is equal to 0, right? So like this, right? So now you can see that, right? So the df is the stuff. So yeah, does it make sense? Okay, let's find out. Right here. All right, df dot subtract dfq, right? So that means we're gonna subtract the dfq, right? dfq column wise. When we see dfq, when we see your operations df minus any df rather. Okay, df any q. Okay? So this is what it is. So now what is our df? df is like that. What is this? 0. So 7863 0 5 3 0 7 0 9 7 minus dfq. Okay, what is dfq? dfq is 707. 707. Again, here के हुन्छ अब के operation हुन्छ?
broadcast.
Now, of course, 707. Again, 707. 707. Oh, we're now element-wise operation. The element-wise now the then of course. So okay, if you look in the first column-wise, so your column, so everything will be 0 because 70 minus 707, 707 minus 707. These will all zeros, all be zeros, right? Okay. About this figure, your is operation one of the. So give 8 minus 7 is 1, right?
1.
It's figure 5
5.
minus 0 is 5, and 0 minus 7 is minus 7, right? 6 minus 7 is minus 1, right? 3 minus 0 is 3, and 9 minus 7 is 2, right? And then finally 3 minus 7 is what? Minus 4. 0 minus 0 is 0, and then 7 minus 7 is 0, right? So now are they the same? Yes, they are. Right? Understand? 0 0 0 1 5 minus 7 minus 1 3 2 and minus 4 0 0. Yeah, right. Okay. So that's how it works. Okay. So okay, so now you saw how we can do operation between data frame and a series, right? All right, so got that part. The preservation and alignment of indices columns means that the operations on data in pandas will always maintain the data context, right? You don't have to worry. It's just, pandas will take care of everything. All right, so the next thing we're going to, so far, do you have any questions, key questions? No? Are you following? Yes, right?
Yes, sir.
Good. Okay, so next thing we're going to talk about is handling missing data, right? So missing data, the real world data is really clean and homogeneous. Many of real world data have some amount of missing value. So you can see real world data, so actual data. So the data, of course, they are messy, right? They are, not clean. I mean, they have to be clean. Custom, right? Jस्तै तपाईले कुनै एउटा जस्तै कुनै एउटा हैन भेजिटेबल है तपाईले तरकारी अनि तपाईले बजारबाट तरकारी किनेर ल्याउनु भयो भने सिधै तपाईले पकाउनुहुन्छ र you don't do that, right? What do you do? First तपाईले त्यसलाई के गर्नुहुन्छ? त्यसलाई मेबी त्यसमा अब हैन कुनै बिग्रेको छ भने त्यसलाई पाल्नु पर्यो हैन? अनि त्यसपछि त्यसलाई पखाल्नु पर्यो अनि पखालेर राम्रोसँग धेरैचोटि 2-3 चोटि पखालेर त्यसलाई चाहिँ हैन त्यसको क्लिन मतलब नचाहिने पार्ट्सहरू अथवा बिग्रेको पार्ट्सहरू फाल्ने त्यसलाई काटेर गरेर हैन एकदमै राम्रोसँग त्यो गरेपछि अनि बल्ल देन यु कुक हैन सो डेटा इज जस्ट लाइक द्याट डेटा पनि त्यस्तै हो तपाईको र डेटा हुन्छ नि जुन डेटा र डेटा हुन्छ त्यो र डेटाको तपाईले बजारबाट तरकारी किनेर ल्याए जस्तो तपाईले सिधै त्यसलाई चाहिँ एनालिसिस इन्जिनमा पठाउनु you cannot do analytics on it or you cannot analyze that data right away. So you need to do a lot of these cleaning, right? Data cleaning, right? This is going on, right? So now, of course, our data, contains most of the time they contain some missing data. With the data, they get the particular points, particular cells. Right? There's no data at all, right? Let's have missing data. Right? So how does pandas handle missing data? Okay. So pandas uses sentinels for missing data and uses 2 Python null values, right? So you would say missing values like represent nan, right? Which is not a number, and you non, right? Nan or non, right? So let's see. The first sentinel value Panda uses is non, right? Non is a Python object. It can be used in any arbitrary NumPy pandas arrays, but only in arrays with data type object. Okay, so say we can simulate that using this. Say the vals is equal to say let's see you're going with me. Okay, so if you look at this, So this is vals. Sorry, vals one. Right? Vals one. Okay. So this is D type object. Right? Object type. You know, like the integers and 1, 3, 4 are integer. They're non. They non-keyword. It's an object type. It's D type keyword object. There's something of customer object. Right? So these are all of customer. We have already talked about it. Right? It's something of customer object. Right? That's one. Okay. So okay. So the mostly say NaN user. So NaN, missing numerical data. Right? The other missing data representation is NaN, which is a special floating point value. Right? So let's say it's NaN. See? So look at this now. Okay, things will change a little bit here. Okay? So here's this vals. So if I do vals 2 rather, right? Okay, vals 2. Yeah. So now these are integers. So 1, 3, 4 are integers. Now np.nan, the data type is float. Right? So if I do type, if I do nan, sorry, np.nan. Okay, so the type is float. Right? Nan could type your float. Okay, your nan right? This go data types are float. Right? So so if I do vals 2, then I get this, because this is float, so all of them are upcasted, right, to float. It's a big float upcast. Okay. Okay. So D type. Okay, if you print the D type, vals 2 for D type, whatever it is. Okay. Vals 2 dot D type. Okay. So if I do that, I get float. Okay. All right. So when you see keyword non-secure, what's the data type of non? Non could you type keyword?
Object.
Good. Okay. NaN could keyword.
Float.
Float.
Okay, float 64. Okay, so NaN is like a data virus, right? Which infects any other object it interacts with, regardless of the operation. The result of the arithmetic with NaN will be another NaN. So NaN operation got it. I think we have already done this before, right? So NaN operation got it. The result is always NaN. Right? You see 1 plus something number, right? Plus NaN. Right? Multiply, division, whatever you do, all these arithmetic operations, sir. What do you get? You get NaN, right? So for example, see here, see, yeah, I can try some of these. See, 5 plus NaN, np.nan, right? See, we get 9 NaN. Okay, we can do, say, any operation, see, okay? So division operations, any arithmetic operation will result in NaN. It's a data virus system. Say, go 1 lakh data, so you're a NaN idea, say, the whole thing, right? The whole aggregation operation, NaN, right? So say if I do have this vals, vals has got vals 2, vals 2, vals 2. So it's the NaN, I know we get NaN, right? So but your NaN will be give over. Now if I do vals 2, np does sum, right? So if I do vals 2, then see I get NaN, any aggregation operation. Mean garo, I get NaN. Okay? So this is problematic. Problem there. Okay. All right. So these are all NaNs. So the good news is that you can ignore those NaN values. And then your corresponding say the sums of it, you just have aggregation operations or methods or numerical corresponding. We have methods that ignore NaN values. Right? Just think, for example, use np.nan sum. Right? Means it will ignore NaN values in sum. Right? Gives us the sum. Right? Vals 2. See? So you'll ignore there 4, 5, 6, 7 plus 1, 8. NaN, let's say ignore there. Right? Likewise, you can do NaN mean. Right? NaN mean. Can you try that? NaN mean. Can you try what does it give us? NaN mean. It's the average. 1 plus 3 plus 4 कति भयो? 8 divided by कति हुन्छ? 3 हैन? 8 divided by 3. There are 3 numbers. 8 divided by 3 हुन्छ, okay? Which is this.
3.
Okay, which is 8 divided by 3. Okay, okay. All right, is it all making sense? All right, excited. So, all right, so we can do it that way. Okay, so let's see, NaN and NON in pandas. Pandas can handle NaN and NON nearly interchangeably, converting between them where appropriate. Okay, so okay, so if we do this, so say S minus vid.series. So if you look at this, see, vid.series 1, 2, or rather, let me show you. Right? So it's 1, 2, and vid NaN पनि छ, NON पनि छ. भने के गर्ने? भन्दाखेरि यसले के गर्ने? NaN लाई चाहिँ NON मा अपकास्ट गर्यो, के अरे NON लाई NaN मा अपकास्ट गर्यो. Like float 64 मा अपकास्ट गर्यो. Right? Got it? Okay. So float 64 मा NON लाई पनि NaN मा राखियो. So rather यो चाहिँ NON थियो, NON लाई चाहिँ NaN मा राखियो. Okay. All right, for types that don't have available sentinel value, Python automatically typecast when any values are present. Okay, okay, so it'll automatically upcast to floating. You guys saw that. Okay, all right. So actually, we did a series range to that we call it int. Okay, so for example, right here, yes, but numpy array same thing. We series so it's just a series. Let's try this one. PD.series. Let's try this. So this is X, which is right. So this is X is the this is a series. It's just rather this doesn't look like it is a series. So X. So it's this a series, right? So okay, so here's the series. So if I set, for example, X, say X1 is equal to np.nan. So if I do that, now see keyword. Change, see on K2, 0, 1, 2, 3 IO, in 64D type here, which I give it 460, np.nan. Yes, in nan IO. This all upcasted, got upcasted to the values upcasted to what? Okay, making sense?
Yes, sir.
All right, so see, I mean, you can look at the table, floating. So conversion rate string at least, okay. So floating points have no change, right? So you can look at it. So operating on null values. Okay, as we saw, pandas treats NON and NaN as essentially interchangeable for indicating missing or null values. To facilitate this, there are useful methods for detecting, removing, and replacing null value. Because, of course, your real world data, as we said, will involve some missing values. So pandas provides us these functions, okay? Give me nice functions in order to deal with those missing values. Okay? So, for example, is null. What it does, it generates a Boolean mask indicating missing value. Right? Not null, opposite of is null. Right? Drop NA returns a filtered version of the data where it drops all the null values. Right? Fill NA returns a copy of the data with missing values, filled or imputed. Okay, all right. Okay, let's look at all of these in an example, in examples. Right there. So, for example, we got this data. Let's see. This is our data. Here's our data. Okay, so this is data right here, right? So I'm using case of missing values, right? We got one missing value, right? So one NaN hello non, okay? NaN picture non picture. Okay? So now it you know the D type object, right? D type is object. So because this is strings, right? Strings. Right? So okay, our ISMA. What we can do is data dot is null, right? Is null. If we do this, let's say this will give us a Boolean mask. Boolean mask just like null true, null false. Right? See? So that means so one is not null, false side. You say yan, say your case, yanera case, but there is some null, that's null. But you say it's not true, right? You say of all crossing, yes, 3 months, 3 months, it's a none is null, null, that's one, that's true. Rather, say one hello, these are not null, we get false, right? Hope it makes sense, right? So very good. So is null it is. As a secret, we have not null. Right? Same thing, and do not null either. Okay? Is null, not null. Right? But not null ma take ultu one. Right? Not null ma take ultu. Give up lady. Or yeah, or you take ultu. They have false and set true. It's a true. It's a take ultu. Right? See, one is not null. Okay, not null. Yes, it's not null. Not null. You know, null sign. That's again. It's true. Right? Then it's not null, it's false because it's null, right? So it takes a rigid hand badger. It's making sense.
Yes, sir.
Yes, sir.
Right? So likewise, we can do, so say, I want to get all the non-null values. See, I can do this. So this is my data. So if I do data, and then data dot not null, right? Not null. I should get all the values that are not null, right? It's the wonder hello, right? Because this is Boolean mask. Okay? So okay, understandably, right? So I can do if I do is null very also.
NAND or none?
Right? 1 or 3. Very good. Right? Okay. So all right, very good. Okay, so now we can drop null values, right? So I can drop null values. Dropping null values. Okay, so how can we drop null values? Let's see. So I have this data. So if I do data dot drop NA, right? Drop NA whatever given. Simply drop values. For example, null, so there's drop. This row got dropped, right? Then this row got dropped. The remaining 0, row 2, and 0, 2, right? So drop and delay, it drops all these rows where even this one, it's not so daily columns, but at least whenever you column and it's the whole row is dropped, right? Put it only drop. Okay, all right. All right, so let's see. We got that part. Let's see. Let's create another data frame and let's see how it works out here. Okay. All right, so here we go. We get this data frame df, which is just df, right? Df. So we use df now. Let's do some operations in this. So if I do df dot drop NA, what do you think? Yeah, so what's your answer? Which one?
First, second.
First or second? Yoda one. Well, first or
Second.
Index 1. Which is good. Right? Index 1, row index. Hey, this one. Because it's not going to be an answer. It's an answer, even answer. So this will be dropped. 0 will be dropped because there's NAND here. And this will also be dropped because there's NAND here. Right? 0 one. Very good. See? 2, 3, and 5. 2, 3, 5. Okay, very good. X. Right? So, okay. So we can do columns. X is equal to columns when you go to meter. So if I do, you have to drop NA. X is equal to, let's try 0. So if I do this, you can see that x equal 0, x is equal to 1. So x is equal to 1 or columns. This is kind of, okay. So df, right? Df dot drop NA. Okay, and this is see if I do x's equal to either I can do columns, or I can do columns because apparently x is equal to 1. So all right, so our it's my keyword. So you look at the columns. So your column, your column, the nan answer is dropped. It's my your answer. This is also dropped. Back it over here. Okay, 256. 256. Okay. All right, makes sense.
Yes, sir.
Let's go back here. All right, so likewise, so we can say, okay, so df3 is equal to nan. Okay, so let's try this. Obviously, df3 this way directly. So if I put df3, so let's try df3 or your column address. So your data frame के हुन्छ नि यसरी हामीले जुन यो गर्छौं यसरी स्क्वायर ब्र्याकेट गरेर हामीले जुन यो नोटेसन हामी गर्छौं गर्दाखेरि डेटा फ्रेममा के हुन्छ भन्दाखेरि यसले चाहिँ कलमलाई सबसेट गर्छ है कलमलाई लिन्छ जस्तै नम्पाई एरेमा के हुन्छ यो गर्दाखेरि रोज दिन्छ हैन एरेमा रोज दिन्छ तर डेटा फ्रेममा के लिन्छ यसले यो नोटेसनले के लिन्छ भन्दाखेरि कलम लिन्छ है त्यो चाहिँ फरक है so that is the difference right obviously thinking df3 or so we're referring to this third column which is not there but we're gonna put it there right df3 equal to here np.nano you see so of course यहाँ up any broadcasting and then so we got nan right okay. So let's do some of our operations. So okay, drop NA, how equal to all. Okay. So df dot drop NA, and the axis is equal to columns. X is equal to columns. So यति नै गर्यो भने के हुन्छ भन्दाखेरि okay कतिवटा आउँछ यसमा
एउटा third column
index number 2 column index number 2
2
okay so but if we do something else if we do something like this so same thing right but how is equal to all so that will change a bit यो गर्यो भने चाहिँ के हुन्छ है see अब के भयो so can you figure out how equal to all ले के गर्यो
जुनमा चाहिँ सबै न्यान छ त्यसलाई मात्र हटाइदियो
that's right how equal to all मा चाहिँ so सबै किनभने यो कलममा सबै न्यान छ त्यसले गर्दा this was dropped these were not dropped because all छैन नि all न्यान छैन so यसमा all छैन यसमा all छ that's why it got dropped okay this one got dropped so I'll stop right here okay please join so please join immediately right